class is a grouping of values by which data is grouped together or binned for computation of a frequency distribution. Consider the two tables. The first table has classes of 30 to 34, 35 to 39, 40 to 44, and so on. The second table has classes of 30 to 39, 40 to 49, 50 to 59, and so on. The ends of a class interval are called class limits. For example, if you consider a class of 30 to 34, it has 30 as a lower class limit and 34 as upper class limit. And when you consider a class of 30 to 39, it has 30 as lower class limit and 39 as upper class limit. A class width or interval is the size of each class. The number of items or values in a class correspond to the class width. Take an example of a class of 30 to 34. The values included are 30, 31, 32, 33, and 34, meaning the class width is 5 since they are 5 values. Similarly, 30 to 39 has values of 30, 31, 32, 33, 34, 35, 36, 37, 38, and 39, meaning the class width is 10 since they are 10 values. However, in practice, to determine the class width, we get the difference between the upper class limit and the lower class limit, and we add a 1 if the values are whole numbers or read to 0 decimal place. That is to say, a class of 30 to 34 would have a width given by 30 minus 34 plus 1, which is 4 plus 1, and it would give us 5. The smallest value in the data gives an indication to the first lower class limit, and the highest value should be accommodated by the highest upper class limit. For example, our data has the smallest value as 30 and the highest value as 57. Hence, 30 can be our first class limit. Then the required class width determines how large our first class should be. For example, if we want a class width of 5, then we list the values starting with 30, meaning we will have 30, 31, 32, 33, 34 as members of that first class, which runs from 30 to 34. We then formulate the next class starting at 35 and keeping a uniform class width. Hence 35, 36, 37, 38, and 39. And thus the class would run from 35 to 39. We continue with the same pattern and generate the next classes until the highest value, in this case 57, is accommodated. Therefore, our classes are 30 to 34, 35 to 39, 40 to 44, 45 to 49, 50 to 54, and finally 55 to 59. Hence, 57 is accommodated, and we stop. Class boundaries are values which separate classes. Any given value has boundaries. For example, 30 lies between 29.5 and 30.5. 34 lies between 33.5 and 34.5. Therefore, the class of 30 to 34 lies between 29.5 to 34.5, with 29.5 as the lower class boundary and 34.5 as the upper class boundary. The lower class boundary over class is the average of the lower limit of the class in question and the upper limit of the previous class. For example, a class of 40 to 44, its lower class boundary will be 40 plus 39 divided by 2, which is 39.5, since 39 was the upper class limit of the previous class. The upper class boundary over class is the average of the upper class of the class in question and the lower class limit of the next class. For example, a class of 40 to 44 has upper class boundary as 44 plus 45 divided by 2, which is 44.5. Since 45 is the lower class limit of the next class. However, in practice, we subtract 0.5 on the lower class limit to get the lower class boundary, and we add 0.5 on upper class limit to get the upper class boundary of a given class if the values are stated as whole numbers or to 0 decimal point. For example, 40 to 44 gives class boundaries of 39.5 to 44.5. Class mark labeled as X is the median or middle item of value of a class. For example, a class of 30 to 34 has values 30, 31, 32, 33, and 34. Thus, the median is 32, which becomes our class mark. Similarly, a class of 30 to 39 has values 30, 31 up to 39, and the median is the average of 34 and 35. Thus, the class mark X is the average of the two, which is 34 plus 35 divided by 2, and it is equal to 34.5. In practice, we get average of the upper class limit and lower class limit. For example, A class of 30 to 34 has a midpoint of 30 plus 34 divided by 2, which is 64 divided by 2 and is equal to 32. Similarly, a class of 30 to 39 has a midpoint of 30 plus 39 divided by 2, which is equal to 69 divided by 2, and it gives us 34.5. With that information, we can use the data obtained by students from the banana plantation garden to form a frequency distribution table as shown.